exciting topic today with our four participants. We will be talking how AI will transform the future of power transmission and motion control industries. And we have very valuable attendees from the industry. Mr. Salim Haffar from iMac Gearboxes, Sean Fang from K2 Tech, Andreas Masuras from Augmented Future AI, and Tiago Camargo from JTEKT. I have very hard questions prepared. let's kick off. My first question goes to Mr. Sean Fang. You work with high-speed production lines where precision is critical. How does AI-based visual inspection improve the efficiency compared to traditional methods? That's our first question.
Yeah, it's a good question. Well, for the efficiency, definitely AI can just increase the efficiency overall on it. So, but I need to just clarify one concept. It's not AI cannot make the cycle time running faster. It's still just still running in the same speed of the production lines. What AI can do is a different thing about how to just impact the efficiency. So in some production line, it always just meets some new defects, always. So it's unexpected. When we want to recognize the new defects, the traditional mode here always need a very long time to do the configuration. So sometimes it can be several days or even weeks. After the configuration, also need to do the fine adjustment on it. It will be a long time. But for the AI part, as I just mentioned, we can do very simple process, about 5 to 8 minutes to do the configuration, and then let the AI training is about several hours maybe. So after that, and it can be recognized. That means the whole product line will only stop for these several hours. This is a huge just increasement on the efficiency. Yeah, because the honing machine, the other machines, if we can stop longer, and it can just be lose many of the cost.
Yeah.
So this is a key point. I think it can help.
Yeah, thank you very much. As K2 Tech, we know that you developed cutting-edge AI and machine vision solutions for manufacturing. So this is our second question. So how do you see these technologies evolving to handle even more complex defect detection in bearing and component production?
I think it's two parts of answers in this question. The first one is about very complicated surfaces. I just mentioned that currently the parts have been integrated more and more than before. It's not as simple as before. It's only one surface. For example, the generation 3 hub, and it's already very high, just integrated. They have several layers of the surfaces. So for the traditional way, they need to just have the segment for different surfaces. That is very difficult and the operator, they need to do it step by step, very complicated. But now with the AI function, we know that there are different area, different surfaces. We only let them know this area we want to detect, and after that they can recognize different without doing some manual segmentation. And it's all done by AI itself. So it can be, treat very quickly. So this is one part, complicated surfaces. The second part is complicated defects types. So these defect types, so traditional defect types may be scratch, maybe dent, maybe rust, maybe some missing material. It's quite simple to know. But in the grinding process, sometimes it will have some missing grinding. It will have some grinding mark. It's like it's not too different with the OK surfaces. They don't have too much difference on the gray scale. So by this, we can just the AI function can do the generalization to learn the patterns of these defects very easily. By this part, and then we can just detect them 100%. So this is how we can just treat it as a big advantage than the traditional algorithm.
Yeah, thank you. Another question for you is, can you share some examples where your technology significantly reduced scrap rates or customer complaints for bearing and power transmission manufacturers? So some real examples.
There are many. So I think I have some, I cannot just say which company, but sometimes, especially in the automotive industry, this happens a lot. So basically, they provide the finished part, for example, rollers or bearings, one batch to their customers, and maybe it's just a very big batch, 100,000 to 1 million parts pieces, and to them, and then the custom, even if they find one piece of the critical NG part, they will return everything. Several options: return everything, or recheck, and the supplier, manufacturer need to cover all the cost. Imagine if the custom they are in some developed country, the main cost what will be? And the third one is, okay, you can send me another batch by free, and also in some very limited time, maybe air fridge only. So this is a big custom cost. So for this part, what we just know before, and some of the customs they face this problem before, and then they found us, and we provide this machine to them, this line solution to them, and after deployment, this situation can be huge, just improved. Even as I know, this situation sometimes it never happen again.
Yeah. It's very good, useful. Thank you. Now we are moving on with our questions. How is AI currently used in power transmission manufacturing?
The first thing, the big challenge is how AI can really just solve the pain point, help them to solve the pain point of this manufacturing, this company. This is, I think, the first thing. So we can just try to convince them that AI can help you on the efficiency or others. But first, if we can align with their pinpoint, and we know if without AI, you cannot just do that. Or with AI, you can do it more efficiently, much more. They will be convinced. And then you can have some cases. This is one part, I think. The first one, the second one, I think is, you know that for the manufacturing, sometimes it's not still some much pressure on the cost control. So by this, if they need to just use AI with very high cost, they will be scared. So if we can just do from some small point and can help them step by step, yes. I think it will be a good chance for them. They can use that, and they have some concern if AI can help us. They have this concern, they will not move. But if we start from a small point, for example, our quality control, this part, and then they can use that with a pilot or something, and can see, okay, AI really has the potential to help us. And then they can check always about the ROI. And then you can see, okay, it really can help us. The ROI is acceptable. Then we can move on, and more, step by step. So in Europe, we have the smart manufacturers now, the concept, and the industry 4.0. So without AI, I don't think it can happen very soon. So I think step by step on it, we will achieve that. Yeah,
yes. Yes, thank you very much.